Welcome back to the third part of our beginner-friendly Ethereum Smart Contract Programming series. On today's agenda, I want to talk a little bit about what the public keyword is doing, the events keyword, throwing errors, generally just working right from the Brownie console itself. So we're going to spend most of our time in the Brownie console. So we're still going to actually have Ganache stands up and launch anyway. So we're just going to let me get Ganache started right away. And while we do that, just going to say quick start. There's our 10 different accounts. We're going to try and interact with more of these accounts, okay? And going back to the terminal, so just going to keep this out, going back to the terminal. And we're going to resume from using the coin.sol, so coin contract. That's the one that we created in the last video. And we're going to do most of the coding this time from the terminal using Brownie shell, or Brownie console. I don't know why I keep saying Brownie shell, maybe because there's a Python, Django shell. Working from the console is a very important skill since we're going to be testing and deploying our smart contract, and we want to really rigorously test our smart contract before we deploy that and put that into a a real live production blockchain. You don't want to just write the code, send it out nowhere to deploy it to a blockchain or something, right? So you're going to have to write a lot of tests, and to be able to experiment with a smart contract directly in the Brownie console. That's going to be a really important skill to have, just to help you out in the process and to assist you in the process. So let's start by doing a quick revision on the coin contract, just like what we did last week in the last video. And we're gonna go ahead and open that up if you don't have it already. I'm still the same contract. I haven't made any changes to it yet. So open up coin.sol if you're ready, and we do a quick revision just like what we did in the last video. And this contract is straight from the documentation, and it implements just the simplest form of a cryptocurrency. And the contract currently allows its creator to create new coins using the mint function. So you can think of different issuance schemes if you want, but we also have a send function that allows us to allows anyone to send and to transact and to interact with our coins and transact and send coins from one wallet to the other, from one address to the other. Okay. So if you're ready, open up coin.sol and we can get started. So starting at the very top, you see our SPDX license identified. We spoke about that. I don't want to get into that again. Pragma Solidity, this is, again, we talked about that as well in the last video. So let's hop right into contract coin. Now we have two state variables, right? The first one is called minter, the second one is called balances. The first state variable is minter, is of a type address, and the second one is balances, is of a type mapping. Now within if you look at the address itself, if we look at the minter itself, this is a type address. We understand what immutable is doing because we explained about that last week, in the last video. And in the last video we said how immutable kind of look like a constant, except constants you cannot modify the value anywhere, but immutable you can actually have it be set in the constructor but not modified anywhere after. So you can't go in here and now and change minter to be somebody else, because that would be a terrible idea, I think, right? Because minter this should actually tells the this should actually store who is the one who initialized that, who is the one who actually sent this contract, deployed this contract, and you want this to be the owner of the contract. You don't actually want this to be anyone, and nobody should be able to modify the value. So immutable gives you that. It says that nobody should be able to modify the value, so you don't have to worry about people coming in there and then setting minter to themselves and then trying to create more coins. Okay, so that would be a terrible idea. But what about public? What is this public keyword actually doing? Now, if you read the docs, you read about this public keyword. What it says is that it generates, what a public keyword is doing under the hood is that it generates a function that allows you to access the current value of the state variable. So it generates, this public generates a function that allows people to access the current value of this state variable, even from outside the contract. So let me show you what it looks like. Okay? Let me show you what it looks like. So if you create a state variable and you have public in it, what it does is that it creates this getter public variable, creates this getter function. Getter is just in programming we say getter is like just gonna get the value for you, and because we say it's a getter value, you kind of know that this should be a view already, right? So let's go ahead and say function minter external view returns. Okay, so there's a handful of things here, but External is because you want to get this using a contract from somewhere else, so using something else. It's not something that it's not something useful to have this mint. It's not a helpful idea to have minter in here so that we can refer to that from, let's say, this one. So it's not really useful internally. Internally it's not useful because you could have just called minter right away like that. So this getter function is really only useful anything outside of this contract to try and interact with the state variable in this contract. So that's why it's external. Sorry for that. Okay, external. And then view basically says that we're guaranteeing that we're not actually going to modify any value. It's just a getter function, just trying to get a value, return it back to you. Okay. Now when we put a returns, we actually need to say what is the type that we're returning here. Now what is this? Address. So what do we think we're returning? Address. So let's go ahead, address, and this is very straightforward. Just return minter. That's it. Okay. So now your Solidity compiler or your linter is probably going to complain and say, hey, identifier already declared because you already did a minter up there, but don't worry about it. But this is kind of what it's doing, all right? So the keyword public, every time you see the word public, same thing in here, it automatically generates a function that allows you to access the current value of the state variable, of this variable, and allows it to allow view access to this state variable from outside of the contract. Without this keyword, there are no other ways for contracts to access the variable. Okay, without this public keyword, if you take that away, then there is no way for other contracts to have an access, to this variable. They will not be able to see who the minter is. Right. So the code of this function, the code of the function generated is kind of what we just what I showed you there. This is kind of what it's doing. But you don't actually have to do that yourself. That's probably no reason for you to want to have to create a function like a getter function for you to do that. If you ever find yourself doing something like get min or get minter or something like that, there are probably better ways to do it. Okay, so you probably would never have to try and implement this manually. You don't on your own, right? So you don't need to do this. The compiler will figure that out for you. So let's remove all of that. Let's not try and reinvent the wheel here. And similarly, because we have mapping in here, we also have a public. So what does it do here? Does it do the same thing with public? How does it work then? Because here we just have to take the getter. We don't have to take any argument. When you call the getter, it returns this value straight up. But here it can't return a value to you because it needs to know exactly what is the address. This is a key value mapping. It needs to take something in here. So it's not as straightforward as the one up there, but it's still doing essentially the same thing. Now mappings itself is just you can imagine it being a hash table. Okay, so it's basically just a key value pair. So all of this key, they will map to a certain value. If you pass me an address, if you give me an address, I'll give you the value. If you tell me that, okay, check my, what is the, how much coins do I have? This is my address. Then this mapping would return a value if I pass in my address. And I can check for anyone else's address and anyone else can check for my address, right? But there is one trick here, is that there is actually, all of this, when they first initialize, they initialize to 0. This is 0. But the trick is that it is not possible to obtain a list of all the keys of a mapping. So even if this is public, you cannot access a list of all the keys on or all the values. You can't. All right. So the getter function looks a little bit different. So how does the getter function looks like that? So let's go ahead. So when you put a public and that is to a mapping, so the getter function looks slightly different. It looks like this. It looks like balances. This function would always be the same name as this because then that's how you would call it. And what does it take? Clearly it takes something. The rest are the same. External, right? Because again, it's only going to be useful externally. If it's internal, you can just reference it already. Why do you need to go and create this complicated process? And it's going to return 256. This is something we learned before. Now, so far, this is very similar to what we've seen, the getter function earlier. But we return unsigned integer 256 instead of address. We return that. But here, we still need to take something, because you need to give it an address in order for it to return something. So what is it that you want to return? So that's going to be, what is it that you want to take in? That's going to be an address, right? Because the key is the address. So let's do that. And we can call it account, and we can say return balances account. That's it. Put a semicolon. So this is the getter function used by created by the public keyword. If you put a public keyword, this is the getter function that it creates for you. In the case of a mapping, is that you still need to pass in the key, the address itself, and it gives you the value. You can't ask for all of the address. You can't ask for all of the value either. All right. So that's and all of this. Recall that we learned about this in the last video. View means that this transaction, this transaction itself is free. It's not even a transaction, it's free. So view itself, it doesn't cost you any kind of a gas fee, right? So let's just remove that, just to explain this concept. Hopefully that's clear. And we can then use the getter function to then query the balance. And this will make a lot more sense, because later on, when we hop into the console, you will see that if I ask you to get me the minter, you will do something like this. You will do something like this, okay? You say something like, this is the coin contract, so let's go ahead and deploy a coin contract. Deploy a coin contract. And you do that by saying something like coin.deploy, and because coin deploy is a transaction, you need a from, and you have to pass in a guy. So let's give it admin. Okay, where is admin coming from? It comes from one of the accounts on the blockchain already. If not, you have to create a new account. Okay, don't worry about that now. But the second step is that you will then say, if I ask you to get the minter or get the owner or whatever. Now minter itself, that's a state variable. You would think that, okay, if I'm used to Python, you would think that maybe what I'm gonna do is I'm gonna say this is the coin contract, and then I can just do a coin.minter. Well, that's not how it works. So what you want to do instead is to call the getter function, so minter itself, like this. And when you call minter, then you're gonna get the actual value of the state variable. Okay, so this is going to make more sense once you understand the process of what a public is actually doing for you. It's not, when you do a public, it's actually going to create that getter function that we just spoke about. And to see all of this in action and to get a bit of to get our hands dirty and get some warm up here and to maybe practice. The more you write code, the better it is anyway, right? So I want you to just maybe open up a terminal. If you use Visual Studio Code, there's control backtick. So control backtick, that will open up a terminal. I'm going to open up a terminal right now. And once you're in the right environment, I want you to just make sure that you can go into Brownie console. If you currently have the Ganache open, you can check that your accounts 2340. If you go into Ganache, 2340 is the same on Ganache. So that's how you can. Let me open up Ganache to show that. Okay, here. So that the first account 2340 and then B330. If I compare that to Visual Studio Code, I see exactly the same thing. So 2340 and then B3306. All right. So so if you have Ganache open, if you don't have Ganache open, it's fine. This is the third part of the series, and here we're really just gonna focus on trying to get ourselves very familiar with the Brownie console. So once we get used to that, we can start to write proper tests. Because I just stress how important tests is. If you write smart contract, and you most likely gonna deploy that somewhere, and people are gonna interact with that with real money, right? You're gonna have to spend some money, whether it's an NFT, whether it's whether you're writing an insurance contract, whatever it is. And because of that, it's very important that you make sure that your code is well tested. So we're gonna go into writing proper tests in the test folder. When you do Brownie, there is a Brownie test folder, and within the when you do a Brownie init, it creates this hierarchy. If you show you tree, it says that it creates a test folder in here, and within test folder right now there's nothing in there. Shut this out. So this is the tree. You see that there's a test folder in here, right? And we're gonna start to write tests in it. But before we get even there, I want to make sure that you're familiar with writing, interacting with your contract directly from the Brownie shell, the Brownie console itself. Because if you're not familiar with that, it's just good to be familiar with it, because it just gives you so much direct feedback, quick feedback. You can iterate, can experiment with it, and once you're familiar with it, you can put them into a script. We're gonna use Python for that. Okay. For now, enough of talking. Open up Brownie console, do a Brownie console, make sure that you're in there, and I can keep the Ganache somewhere open, but I'm just gonna mostly work with my console from here. Let's go ahead and check, do we have any contracts deployed? If you go into your Ganache and you click into your blocks, this is you know, the first initializing the blockchain transactions, doesn't take any gas fee, and there's no transactions, just 10 accounts. Cool. Now let's close that out. What about contracts? Let's do a contract. Let's do a coin. Well, it's a Python array of 0. Okay. This is a Python array. Give you nothing. Why? Because we haven't deployed anything yet. Right? We haven't deployed anything yet. Same thing for simple storage. It's an array of 0. Why? Because we haven't deployed anything yet. Okay, we haven't deployed anything. So let's go ahead by first deploying our coin contract. Let's deploy one instance of the coin contract and put it on the blockchain so that we can see it on the blockchain. We have an address that we can work with, and we can interact and use the methods from this contract. So to do that, we're just gonna say coin.deploy, and this is a transaction. If you go and look at the Ganache later, you will see that this is a transaction, especially in particular, this is a transaction of the type contract creation. So when you look at the transaction later, you see that there is a type of transaction. This is the type, a contract creation type. All right. So for because it's a transaction, it needs to be deployed from somewhere. And so whose account would it be? Now there is a list of 10 accounts, right? So why don't we just go and take the first one, and we're gonna say that's gonna be us. You can call it anything. You can call it owner. You can call it me. But I guess because the terminology that we're using here is minter. Minter is like who is doing the mining, the guy that mint this contract. So I'm just gonna use the same terminology just to have a bit of consistency and not to introduce too many terminologies in here. So minter is it. So I'm gonna say minter takes the first one, and then what I'm gonna do is I'm gonna deploy the contract. So coin deploy. Now it's a transaction, so it needs to go from somewhere to somewhere. So say from this accounts 0. So what I'm doing here is I'm deploying that to the blockchain. But since I already said minter refers to the account 0, then I can just straight up do a minter like this. And if I do that, bam, it's done, deployed. So you can, if you got used to writing account 0, you can stick with that, I guess. But here, you know, I already created, I said account 0. Minter would always refer to account 0 anyway, and so it's the same thing. If I look at account 0 and I compare that, is this the same as minter? Now double equal signs means equality check. It is true. It is the same. If you look at the address of this and you look at the minter address, it is the same. So there's no reason for you to wanna, you know, try and alternate too much between them. So it's deployed. It says I send a transaction, and now the contract is deployed here. Okay, so transaction is sent. So every time you try to interact with the blockchain, you try to maybe change a value, modify a value, delay the value, deploy a contract. Every time you try to change the state of the blockchain, you do so by a transaction, and every transaction incurs some sort of gas. So you're actually spending some gas in order to manipulate or to alter the state of the blockchain by a little bit. So that's the transaction. It gives you a confirmation there, and it also says that, well, it needs to sit somewhere on the blockchain so other contract can find it. Other people can write code that interact with your blockchain. It needs to sit somewhere. There needs to be an address for where it is on the blockchain. There's so many other things going on, right? So this is the address. So don't confuse the two of them. Now, if you go into Ganache now, let me open up Ganache now. And if you take a look, this is the same as our minter address, right? 234. If you compare that to the one you see in Brownie, that's exactly the same. 234. Okay, that's the minter, right? Then if you look at the blocks, you see that now there is one transaction in a new block. There's a new block, there's one transaction. Click on that one transaction, it says this one, and it says this is the created contract address. This is exactly the same as what you see from the console itself. So let's compare that as well. If you look at this one, you see that this is where it's deployed at. coin deployed, and you compare that back to what you see in Ganache, you see that's exactly the same. All right, and who is deploying that? That's from the from address. Again, it's exactly the same as the owner, the minter. All right, so this is the transaction that happens. This is also exactly the same. So this is kind of a way for you to interact with the contract to see what's happening, but you can see all of this information directly from Brownie anyway. All right, but let's go back to or maybe we can click on the transactions just to make sure we see that. So you know, all of this here. Now you should also see that the minter have added one transaction count. Yes, one transaction now. All right. For now, you know, that's not really something of our concern. We can just go back to Visual Studio Code, but just understand that everything you do, everything that you see on Ganache, you can see it from Brownie anyway. Okay, and now once we have that, we have a contract, we have the minter. Now let's go and test some of these methods that we write, or some of these functions, or some of the state variables that we write. All right, so I want to maybe start from, if you look at the contract itself, you see that there is two state variables. Let's do the first one and then do the second one. Let's start from minter. So I want you to go ahead and try and do something like this, right? You say, oh, let me see if I can have my contract. Where is my contract? Coin. There's so many coin contract later on when you keep on deploying the same contract, but right now there's only one of them. So I'm just gonna call coin contract, and I'm gonna just point to this one item here. So you can do it either just do 0. In this case, it's just 0, or you can just say take the last one, -1. Just a small tip here is that in Python, when you put a -1, it says within a list, take the last item of the list. Okay, so that's -1. So last item of the list, that's -1. The first item of the list, 0. All right. So in this case, doesn't matter, it makes no difference, exactly the same. So we're just gonna do that, and that would now point to this contract. Just point to this the contract that we just deployed. Okay. And if you say coin contract, I think you can do address as well. You see that points to the address, which is exactly the same that you get from the Ganache, when you see on Ganache and you see in Brownie as well. So that's cool. But how do we check for the minter of this contract? Now you can just say coin contract, and you'll be tempted to say, well, I can just do a minter. You can't, because you do that in Solidity by just calling it minter, but remember about the get function that we talked about at the beginning of this video? Remember about that? So we are actually going to use the getter function, right? That is created. So when every time you see a public, it's creating a getter function for you. So what we're going to do is we're going to say minter, just like that. So press enter, and we get this. This is the minter. Is this the same guy as the minter, or is this the same guy as the first account? Let's check that. True. So this is how you write tasks later on. You're gonna do some assertion. You're gonna say assert that this is equal, and this is, you know, this is the same as that. You can do that, and we'll talk about that later when we actually write our tests. For now, just get used to writing in the Brownie console, and just to make sure that you have basically all of this syntax nailed down. You have all of this covered first, and then you go in there and write the proper test. Okay, so make sure that you check, okay, so minter is correct. It is in fact the same as the first on the accounts list, which is the same as the minter. Okay, so I want you to maybe, if you can, try to pause the video and try to write along the code, and not just, you know, passively watch it. Try to actually have the terminal open up and actually write the same code in there. I think that's just good for you anyway. Now what's next is we're gonna try and take a look at the second state variable, balances. Okay, so again, we're gonna just walk through this coin contract from top to bottom. So the first one is done. Second one is balances. How do we deal with these balances? So same thing, coin contract. You'll be tempted to do a balance and then just call it, but it won't work. Why? Because in the getter, it asks for an address. You need to give it an address. If you don't give it an address, it doesn't return a value to you. So if you try and do this like this, you're gonna get an error. In fact, you can go ahead and just press enter just to see the error, just to know that this is, it is doing what you're expecting. Let me just run that for you. It says balances sequence has incorrect length. It expected 1 but got 0. What does this whole thing means? It means that it expected 1 argument, but it got non-argument. So it expected 1 argument somewhere between these two curly brackets, but it has nothing in there. So it's complaining about that. So how do we do this? How do we properly call for the balances? We have to pass in an address. So we can go ahead and pass in the minter address. You can do this like this, minter.address, and you get 0, that's fine. You can also just ignore the address, because Brownie is smart enough that if you pass in an account, an instance of account, it's just gonna take the address anyway. So this will also work. Okay, so far you have nothing. There is no balances for this coin contract. Why? Because we haven't actually created any coins yet. That is gonna be done using this min function. Okay, the min function, this is the one that actually creates coins, kind of like out of thin air. This process, they call it like minting it. Mint, it's kind of like put it into existence. Okay, so this is the function that allows you to create coin out of thin air, and this is actually what we're gonna do next, because if you don't have coins, you can't actually do any kind of testing and stuff like that anyway. It's also important that you make sure that this min cannot be caught by anyone else. Okay, it cannot be caught by anyone else, and so it's really important that you take extra precaution, because otherwise this is going to be such a terrible idea. You're going to introduce hyperinflation. This is not a sustainable economic model, or rather make sure only minter gets to call this, otherwise it's a bad tokenomics. Just bad tokenomics. This is a bad idea. Okay, so don't want to have everyone calling the minting and then just creating coin out of thin air, and the coin has no value in that way, because everyone can create it. It's infinite supply of that. Not technically infinite, because there is a unsigned integer anyway, but anyway, that's kind of something we talk about later. That's up to 256. But for now, you don't want to have that. You don't want to have that. Okay, you want to make sure that this is only caught by the minter. So that's why we check for this require. Okay, so let's go ahead now and create some coins for this guy, for the minter guy, for the owner of this contract, the guy who created the contract. Let's go ahead and do that. So let's do that by first calling the mint function and then check for the balances again. Okay, so let's go ahead and say coin contract. What do we want to do? We want to call the mint function. So let's do a min, and what does it take? It takes two arguments. The first one is an address, and the second one is amount. So who do you want to mint? Who is minting, and how much coin do you want to create? How much coin do you want to put into existence, and basically put this into the balances of this guy, right? So just out of nowhere. Okay. So how do you want to do that? So first thing, receiver. We already have the receiver address anyway, and that's minter. So let's do that. You can do minter. You can do minter.address. It's the same thing. We're just gonna stick to minter. Put a comma. The second one is the amount. How much do you want? This is completely up to you. It's find an amount that fits you. I'm gonna just say gonna put 10,000. Just be simple. And then because this is a transaction requires you to have the from account. How do you know it's a transaction? Well, it should be a giveaway that you're actually modifying some sort of state variable. Should be a transaction. And also, by the way, the transaction, the from guy is going to be the message or sender guy. So if you put in something like this, and you put in from, and you put in something like this, it's not going to work, because this is going to fail the require. This is going to fail the require, because this is not the same as the guy who minted it. The guy who minted it belongs to the first guy. Okay. In other words, let me show you what I mean by that. This guy is the one that minted it, not this guy. So only this guy can call that. Okay. So when I fix that error, so account 0 and coin contract min done. Whoops, account is not defined. Account's not account. Do that, done. Okay, so now there's another transaction that just happened there. Another transaction that just happened. And with this, now we can go ahead and do a coin.contract, and we can now check the balances of the first guy, the minter guy. So let's do minter. Voila, 10,000. So congratulations, you just created 10,000 coins, put them into your balance. This is the logic. It says put them into your balance. So you just done that, and so now you have 10,000 coins. Okay, if you want to check that in Ganache, you can do that. Let me just open that up. And if you go into transactions, you see that there's a contract call, and you see that there is the sender address to contract address, and that just happened. Okay, so obviously nothing's to change on your Ethereum, but you just create coins and you put it in here. Okay, and you check the logs. You can also see the same thing in here, but that's about it. So let's go back to our Ganache. And so you can see now that the accounts is still there, but you see there is a blocks, and that just happened. There's a contract call that just happened. So if you compare to the previous two, this one is a contract creation, but now this is a transaction, and that just happened. Who is calling it? Here. This is the from address. Where is the what is the contract address? This one. So this is our admin, our minter, called the contract address and used some gas in order to affect that transaction. Okay. So let's go back to our Visual Studio Code now. So minter, the guy that just minted it just received 10,000, and now if you check for the balances and you check another account, you should see that none of them, they're still gonna be 0. Just the guy that just minted. So minting is just a way for you to just create out of thin air. Just say, okay, just add this. Just go to the balances mapping, find the guy, the key that belongs to the minter, the owner. Just add 10,000 to it. Okay. So the mint function sends this amount of this newly created coins to some address, and this address, in this case here, is us. But it can also be used to send to this address that doesn't belong to us. So for example, if we're the owner of this coin, we can actually call mint and pass some coins to somebody else. Okay, so we can say, hey, I want you to just mint, create another 5,000, give it to somebody else on the team. Okay, so as long as the sender is always is the admin, is the guy who created the contract, is the minter, then this call will always succeed anyway. So you don't have to use mint to give yourself. Only you don't have to think about mint like, oh, I can use that to create new coins to give it to myself, and then I can take that and transfer to other people. You can actually just call mint and just give it to somebody straight away. Let me actually show you that. Let's go and create another guy. Let's say we have a collaborator. A collaborator is somebody who collaborate on this project, who help us with the QA, check our code, do our testing, look for bugs, and maybe help with community management. So we call this guy a collaborator. So let's do collaborator, and we're gonna go into accounts, and let's call the second guy. Oops, first guy, this one, second guy. Okay, so second would be index of 1, and let's see if this will work. Coin contract mint, and the address will be the collaborator now. And how much do we want to give this guy? We give him 5,000, or her. Give her 5,000. But again, it needs to check the message sender, right? So let's do this. Like this. Now you should expect this to work, because this mint function, it just allows you to send any amount of newly created coins to anyone as long as the required condition is met. So here, the require really doesn't stop you from sending out to anyone else's account. You can do that. You can change this and say, okay, maybe do another require that the address. You can do another require where you say that the address itself, the receiver, must be the same as the minter address. You can do that as well, but we didn't do that. So the logic of this function basically allows anyone to just call mint, not anyone, but as long as the guy can pass off as a minter, as long as the guy is a minter, you can call that. You can create new coins and put them into people's balance. So if we call this, it should still work. Done. It still works, right? So we see that, okay, if we check for the balances now, if we check for the first guy, it's still going to be 10,000. That's the minter. The collaborator, 5,000. Third guy, 0. That's cool. So this is the minting function at work, right? Now I want to talk about one thing here, is that if you allow anyone to just create any coin out of thin air, would it ever arrive at a theoretical maximum limit? So the answer is yes and no. Now, first of all, you can create as many as you want, but you need to be aware of this phenomenon, because anyone can, the creator can mint as many coins as they like. So it will lead to this phenomenon called the overflowing. Okay, like they will call integer overflow, for example, or you heard of like integer overflow or underflow. Underflow is that when it goes down to 0, and let's say this is an unsigned integer. Unsigned integer means that the value, there is no sign, there's no plus or negative, there's no -2, there's no -4, okay? There's only plus sign. And if you have a 0 and you -1, and you -1, now it underflow, because you know, it's gonna say that, hey, look, I cannot go down to a negative number because I'm a unsigned integer. Unsigned integer means that there's no sign, there's no positive, negative, right, in a way. And overflow is the opposite problem. So let's say we create an overflow problem. Let's say we have a maximum limit of you know, this is unsigned integer 256. So this is gonna just be 2 to the power of 256 minus 1. Okay. So this is the maximum amount. If you keep minting accounts, minting more amounts, and giving, you know, the guy giving your account more and more coins, once it arrives at this maximum, what's gonna happen is that it's gonna try to wrap around, and now you go down to 0 again. So this is what typically happen in the overflow situation. Except in Solidity, it doesn't happen that way because of this. There is this idea in Solidity called the check arithmetic, where it sets up this. In the past, you need to use a third-party libraries to sort of guarantee that, but for now it's really in there anyway. So you don't have to worry about the overflow phenomenon, but you need to be aware that that could happen. So when the balances of plus this amount, if let's say this is already at the maximum and you add some amount that brings it over the limit of this 2 to the power of 256, why 256? Because it's unsigned integer 256. If it brings it over to the maximum amount of that, then it will sort of revert the whole transaction. So if you're not trying to go to 0, your balance is not going to go to 0. It won't happen. It will prevent that, but it will revert this transaction and say the transaction failed. You didn't manage to take effect. Okay, so that's something that you need to be aware of. This is a very, I wouldn't say very, but this is a pretty common phenomenon. This is quite common, not just in programming, in smart contracts and stuff. It's quite common in areas like game. I don't know if you played games before. Like there are games where, you know, let's say you have a hero power and your hero power is super high, you know, some crazy high about power. Shouldn't have that dash, something like this. And then you buy a top equipment that puts it over the top. You know, you add another equipment, or let's say you have a high power that is like something like this, and this is the maximum limit. But then when you try to add a 1, instead of going to, you know, whatever amount, because there's no more places to display that amount, this is the full display of that, it becomes 0 because it wraps around that. So there is also, you know, this kind of phenomenon happens. If you want to read up about overflow, just look at the Wikipedia entry. There's a lot of very interesting entries on that. You know, if you play Civilization, there is a meme called the Gandhi nuke meme. Gandhi is supposed to be a very peace-loving guy. So one of the attributes of Gandhi is that he has a very high attribute in terms of peace-loving. He's very peaceful, right? But there are certain elements in the game that causes him to even increase to be even more peace-loving, and that tips it over the scale, and it wraps it down to 0. And then he started nuking other people. So he go into from a pacifist to an aggressor, because it wraps from, you know, a theoretical maximum of 9, it wraps it to 0, and now it becomes aggressor. And so that's the whole like nuke Gandhi meme. No one is able to verify the story. I mean, I don't know if I don't, but I mean, it's a legend. It's a legend, and you can read up about that if you heard of the Gandhi nuke. You play Civilization, you heard of that nuke, you heard of that meme. That is the one example of an overflow. So just be aware of that. You don't have to worry about anything right here. It wouldn't go down to 0. It would just revert the transaction. But just be aware of this phenomenon. Know that it could happen. And when it happens, you know where to check. You know which part of the code to check. All right. So we have the balances in here. We've done this, and now we minted this. So if we go ahead now and see what have we covered so far. We've gone through the coin. We've done the state variables, number 1, number 2. We've done that. We haven't done the send yet, but we talked about the constructor in the earlier video. We've done the mean. So really right now what we need to talk about is the error, the insufficient balance error. Okay, and this is probably also a time to maybe write some code as well and try to let's just try to get an error first. All right, let's just try to get an error just to see, you know, how it looks like when we have an error, when you have a message thrown out, when we have a error thrown back at us. Okay, so let's go ahead now and do a coin contract, and I want to be able to call the send. Okay, and within the send, where is it here? I need an address and I need an amount. So if I were to try and send something, and I want to send, let's say, let's just check for the balance. Oh, there's 5,000. I have 5,000. This I'm using from, let's say I'm the collaborator. I want to send more than 5,000 to somebody, to another account, for example, to the third account, for example. So let's say who I want to send this to. I want to send this to accounts another person. And I want to send 5,001. Okay. Now remember, I only have 5,000, but I'm going to send 5,001. Okay. So just to see what happened. And here you're gonna put them from. Here you're gonna put a collaborator, because that's who's gonna be sending this transaction. And let's see what happened. Coin send reverted. Doesn't happen. Why? Because you just don't have that. It says required balances is greater than the amount, and you just don't have that. So it just revert that. It just revert from it. Okay. Now that we see how when it failed, now let's go ahead and try that. But this time let's send it properly from. Let's give our collaborator some coins, because he's been doing all this testing for us. He's been doing the QA from us. So let's go ahead with the minter. We're gonna send the collaborator some coins. Okay. How much coins do we want to send? So remember, right now we have 10,000 coins in our balance. How many coins do we want to send? We want to send, let's say 77. Pick a number, up to you. Okay. We're just gonna send this 77 coins to our collaborator. So this guy right now have 5,000. We want to make sure that at the end of this we have that collaborator would have 5,077. Just to be able to track that, let's go ahead and just do a TX. And let's try and do that. Run it. Okay, coins confirmed. So let's go and check the balance now. Okay, balances. We want the collaborator. 5,077, perfect. So this is great, because we now confirm that we managed to transfer 5,000, and you can do the same thing for Minter just to see what's a new account balance. 9,923. Okay. Now, from top to bottom, we have gone through the error. We have gone through the state variables. We haven't seen the event, so maybe we should try and do that. Okay. So I want to maybe go ahead and do a min now again. Just to mint to another guy. I'm gonna say mint. Let's go and give it to somebody else. Let's create another account here. So we're gonna mint, and we're gonna give 100 coins. Okay, for this new account, and it needs to be from somewhere. Can it be from collaborator? No, because this will not pass. So it has to be from the minter. And again, let's track that as well, TX, because what we want to do now is to see whether or not the emit has happened, whether the event has happened. Okay, well, so I want to see this event being called, right? So let's go ahead and do that. Oops, account is not defined, so let's go ahead and fix that for real quick. Okay, done. So if we call TX, that's a transaction. Okay, if we call TX and we have the we have a number of attributes in here, but the one thing that I'm really caring for is the event itself. So let me do a tx.events. Nothing in here. Why? Why do you think our event is not being fired up? Well, the reason why our event is not being fired up is because this event is emitted with the emit keyword, and the emit keyword only exists within the send. It doesn't exist within the mint. Okay, so because it doesn't exist within the mint, there is no emit here, unless you want to do an emit here. So that's one thing you can do. But in order for you to track that events has happened, you need to call on a function that has the emit. All right. So let's go ahead and how much coins do we have left now? Let's see. Minter 23. Let's give 23 away to the new guy. Okay, let's give 23 away. So let's go ahead and say coin contract send. It takes two things, the address. So this is gonna be account number 2, I believe. Yeah. So this is the third account, and we give 23 coins away, and that should do it. We just have to finish it up by passing in the from, passing in the minter, and whoops, I keep forgetting about the accounts. Let's do that. Okay, so now we see that the transaction has happened. Oh, and we forgot about the send, so the TX. So let's do it TX. Let's do it this one. Let's now create another 100 now. So now that we've done that, we send another 100 coins to the third account, and we just to be able to track things, we put it as TX. You can use as a convention. TX is a good convention to sort of indicate that there's a transaction, or TXN is also a way to say there's a transaction. I'm just gonna keep the TX now because that's what I named it already, and I can just go ahead and say events. And bam, now I see it. This is a bit messy, but if you compare that, if you copy this and you open up your Python deploy.py and just go to somewhere, paste it in here, and just do a quick format, you should see more clearly. It goes from this to amount. And if you check the accounts, this is the minter. That should correspond to this, completely correct. And then 2, it should go to this third account, which is this one. Again, it's correct, and then that's the amount. Okay. So the way I do that is I just paste it into a Python, and I just hit on the Control Shift P, and then just click Format Document. So when you go back into the console, you can still see tx.events. That's there, but you can also say, okay, what about? I want to check the events of what? Let me close this one up now. I don't want to save that. This is called send. I want to see how many times when itself. Let's say there's a lot of event. Let's say I have multiple of this event, right? But I just want to track that. I can actually just use a key and just say send, and it would just give me exactly that. You can do that. You can also just check that. Take the first one and just call for the name. You can also see that it's send. So if there are multiple events being fired out from that transaction, you can just try and drill it down and like, okay, I just want to see events, the send event. I don't care about other events. You can do that. You can also say, just give me the first event. What is the name of that? You can also do that. Okay. So there's a lot of helpful utilities and tools that are built in here. And if you use this contract to send coins to an address, you will not be able to see anything when you look at the address on a blockchain explorer. Now, because the record that you send coins and it change balances, those activities here, some of these activities that you're doing in here, they're not reflected in there. There's only in this part of this code logic. So what you're doing is that you're actually trying to record that somewhere. So you're trying to use events to basically create this link to the blockchain explorer, allowing you to track the transactions and the balances of your new coin, but also you're able to see who is doing what to that. Because if you don't emit this, this kind of things, kind of think of it like a console log if you want to. But let's say that this, every time that this function has happened, you want to do this, and then people can subscribe to that. So when this event has been caught, then run something else or do something else or update the UI or to show the UI and change the button color or whatever and send a success message and stuff. So these are things that you can do. Okay, and finally, because events are quite important, you can also say events. You can just do a quick count as well. You can say, okay, again, you want to pass in a name. So here you can either just copy and paste, or I'm just gonna hard code it and say send. I can say how many times has it been fired in this transaction? 1 time. So you can do all of this stuff. Right. So now just to keep track of everything that's going on, let's go ahead and just do a coin contract balances, and let's check for the minter. Okay, that's 9,100. Let's check for collaborator. Okay, the other guy we don't really care for. We're just doing that just to see an example. And let's also see what is it that the block. What is the latest block number now? Because we've done so much of work already. Okay, 8. Okay, so we've already done 8 different blocks now, and we see all of these things that that's happening. I want to maybe talk about one other thing about error message, since just now I just barely touched on it. So for example, if I try again now, I'm trying to use the collaborator to send some coins to the minter. So let me go and do that. Coin contract send. It needs an address, so that would just be the minter. It needs an amount, so that would just be 5,078, just to have it fill. And then I want to have that's it, there's 2 of them. Then I just want to have the send from. Okay, so all right, so I have my coin contract. I want to send the minter, I want to send 5078. So again, we're gonna fail. We're gonna see an error. But I want to see what kind of error message do I get, because running error is very common. You keep getting error. Alright, so that's reverted. Okay, it's not working. It's reverted. But can we see the error message? So let's print out TER error. So it says it is indeed a transaction receipt error. It says it failed. It did not go through. It reverted. We can also try and see revert message. There's nothing in there currently. And why is there nothing? Well, because we didn't really give an error message. So this is one of those areas we can improve our code for. We can try to optimize our code and improve our code. So when we call this function, it first checks that the balance has to be greater than the amount. Here it failed because it needs to check that this is what you want to send. This is what you have. So obviously, don't have enough to send that. So I guess we can add an error message. And the way you do that is to put a comma after require, and you put in a insufficient balance. Cannot perform the transaction, or something, up to you, or not enough balance. Whatever you want to say there, but it's good to add some sort of error message to sort of tell the user what's happening, right? So using error message like that properly, that would allow you to provide more information to the caller about why a condition or operation failed, because otherwise there is very little information to troubleshoot here. There's not enough information to know why exactly. Is it a privilege issue? Is it because I'm not, like, what is it? Balance? Is it, what is it, right? So when you use error properly, you allow this to revert, but you also pass the message down, and you provide a name to this error and give some sort of context to that error. And this can be this can be useful in terms of troubleshooting, but also useful for the front-end application. For example, if you have a blockchain explorer or some sort of front-end app, NFT app and stuff, then the NFT app can say, hey, you cannot buy this NFT because you don't have enough balance. So you give some sort of context, and the front end will be able to use the information and pass in a proper feedback for better user experience. And then for your developers, for blockchain engineers and stuff, it's also appreciated because you can more easily debug or react to this error message. All right. So the send function, just to summarize that, it can be used by anyone to send coins to anyone else. If the sender does not have enough balance, does not have enough coins to send, then you just throw this out. Okay. If you remove this, what would happen? Well, you can, it still works, because it will still check that this is not greater. So it would, we don't need both. We just need either or. You can keep this, or you can use this. They're functionally the same, completely identical. So you can have this, or you can do this. This is the same thing. You say that, okay, if the condition, if they indeed have less amount than what they want to send, then you quickly revert. And when you revert, throw an error, and in the error, give them the amount that they requested and balance available. So this is also another way to sort of give some sort of feedback and say that, hey, there is insufficient balance. This is a type of what? Of error. Because in Solidity, the type is always at the front. So you say this is a type of error. So throw an error, and don't just throw any error, but give them the context. Say that this is how much you wanted to do to send, but this is how much you actually have available. So you can do that. So there's so many ways to deal with this, but for now I'm just gonna maybe just skip this one. You can remove this one if you want to. And so this is the require and the if statement. So if you want to, you can just make the modification. But if you want to make the modification, you need to know that you make changes to the contract. You need to redeploy this contract. So you need to exit out of this, and you need to then throw a. Do you want to do that? I guess we can, right? So just do that, and you have to do a Brownie compile again because you make changes to it. So Brownie compile, wait for it to complete, build artifacts is there, and then you go into your Brownie console again and redo the process. I'm probably not going to do that because it's going to take too much of the time repeating the same ideas there. So we're not going to do that, but you can. Let me just talk a little bit about the about throwing out errors and stuff like that, and just to give you some sort of historical context about why this is a useful feature and why this is important. So prior to the old way, if you use if you look at some old books on Solidity or some articles that is outdated and some tutorials or whatever, you will see that there is an old way of doing things. So, for example, in the min function, the old way of actually, like if you use Solidity like 0.4, 0.10, 0.5, some of the older ones, right now we're in Solidity 0.12, but some of the older ones, there is a very common pattern for enforcing this kind of permission. For example, here, instead of doing require, you will see something like this. You say something like, if message to sender, if this is not the owner or not the minter, you see something like throw, like this. This is quite common. It's a pattern that you see, and here it's saying that expected primary expression. You don't need to, so just one, like that. But now, if you try to use it on 0.8, 13, or 12, you will see that throw is deprecated in favor of revert, require, and assert. So throw basically does the same thing. It says that if I come in here, if this is not the same as the minter, just throw. Throw is the same thing as just throw and revert. This is not deprecated. So it's not recommended that you do this. Instead, what is recommended you do is that if you still want to use the if pattern, you want to use something, you want to call a revert somewhere in here. Okay, you want to do some sort of revert in here. You want to do a revert and then do something in there, or you want to do something, some sort of require, just like what you see up here, or you want to do some sort of assert. Okay, same thing in here. You say message to sender, like this, right? So it says that it's deprecated in favor of one of these two. Now, what revert would do, if you look at this revert, what it would do and what this require would do, they both will undo all the state changes and it will refund any remaining gas to the caller. So it will say that, okay, if you call this transaction and you perform some actions in here, perform some computation in here, that is going to take some gas, right? But once it hits require, it says, okay, any gas that is not used, any leftover gas, that should just be returned and refunded back to the caller, so you don't end up wasting these guys' money. Okay, so require is quite commonly used in checking for this kind of like valid condition. So for some sort of like input validation, it's very common. You say that, okay, when I check for the amount, this amount must not exceed that. You should have enough amount. You should have enough in your balance to be able to send this amount. So when you use it properly, the require function allows you to just check for all these conditions, okay, and make sure that things are good before it move on. So this is require is kind of common in a contract when you, for example, check that this is a function that only the owner can call or only the collaborators can call. You can do that. It should be considered a very normal and very healthy occurrence. People should expect that it is within expectation that you see a require and okay, you're not a collaborator, hence you cannot change the value of this, or if you're not an owner, you cannot min or whatever that is, right? So this is considered a very normal and healthy flow of that. A proper contract, there should be some sort of require, just to make sure that there are logical constraints on things and you expect to see them. Assert, on the other hand, assert is somewhat similar to how you would think about assert if you're very used to programming in languages like Python and JavaScript, and you build apps and you do some sort of unit tests and you use like assert and stuff and you see assertion everywhere. It's kind of the same way to think about that, because when you assert, you're saying that this should not happen. So you're saying that there is some things are broken. So there are certain things that are broken that leads to this. So for example, you would use require, just rule of thumb. If you use require, you check that, okay, the balance is here, this amount is not greater than the balance itself. These are all logical, I guess, logic gates of like Boolean, whether it's true or it's false. If it's false, you can't do that. If it's true, it's do that. Then you can also try to validate the response that you receive. That's also very normal. You say require, and then when you send this amount, require that you get a receipt back before you proceed to update the balance. So if you don't get a receipt, don't update the balance, for example, right? So these are all the ways you use require. But assert, on the other hand, is kind of like, this should not happen. Something is wrong here. For example, I can add an assertion in here. I can say something like this, and I can say at this point, up to this point, I can assert that the new balance after you send should be lower than the old balance, right? So in a way, I'm saying that, right, I haven't really created that, so I guess you can go up here. You can say check for the old balance. The old balance is basically just the balances and stuff. You can just take that, create a copy of that, and you can say unsigned integer 256. That would just be the balance of the message sender, and you say this is the old balance, and you take this as the old balance, and then you take a new balance. This is this is after it's done. So you basically, and let's go ahead and just finish it out. 256 new balance. And you check that, okay, after this action has after that transaction has been has happened, you update the new balance again. You say that, okay, now check that the new balance should be lesser or equals to that, because if you actually, probably you don't want to send 0 because that's going to cost you gas fee. It's probably not a logical thing to do. So you can check for that. You can also check for example, assertion. Another assertion example is, let's say you can think of, no matter what happened, the balances, let's think of an example here. It should never exceed the total supply of your coin. Let's say you have a total supply of coin somewhere. Okay, so let's say you have up here, you have a total supply of coin somewhere. So every time you mint new coins, you add to a total supply. So you have an unsigned integer again, 256. You have a total supply of coins, and then you say that no matter what happened, nobody should have more coins than what is already in supply, because then it means something is wrong. It means something is terribly wrong, right? So assertion is really kind of that. It's kind of saying that, it's useful for checking like overflow, underflow. If you're saying that, if you're saying something like a plus b, x equals to a plus b, you're trying to assert that no matter what happened, x must be greater than b, especially if a is integer, is an unsigned integer, meaning it can only be positive number. If that's the case, then no matter what a is, after the operation of a plus b, you should always expect x to be that. If this is not the case, then probably underflow or overflow have happened, right? So that's another case you can think about assertion. So these are some examples. So assertion is kind of a way to say that, hey, something is wrong. We don't expect this. It's unexpected that has happened. So that's kind of the difference between how you use assertion and how you compare that to using, for example, something like require, right? And I think we can talk more about the details later on. But for now, this is probably all we have. So let's do a quick check on what have changed. We added a few comments, that's okay. We've changed the amount in here. We added the comments as well, that's fine. We added a message in here, that's fine. So with all of that said, we can now go ahead, quit it out. If you have done a compile, that's good. If not, you can do a compile now. But what we're going to do next is we're going to now go ahead into the test folder and actually start to write tests. And that's probably a time to put a cut here and maybe move on to the next video. So that's about it. So we learned quite a lot in here. I think the best way to really get yourself very familiar with this is to just practice. So pause the video if you need to, just follow along the code. And once you're done, on the next video, we're going to start writing actual tests. So we're going to put them into the test folder, write tests in Python, and actually very systematically test all these different features and these different functionalities. So that's it for today. That's all I have. You have a great day. See you.